Hey guys, welcome to another video on A-level physics, and this time we are doing May-June 2015 QP52. So, a student is investigating how the intensity of the reflection of sound from a wall varies with the thickness of foam attached to the wall as shown in figure 1.1. And it is suggested that the intensity of the reflected sound is related to the thickness of the foam by the relationship I is equal to I naught E minus sigma PT, I guess, where I naught is the intensity of the sound before reflection, P is the density of the foam, and alpha is a constant. Right, so you need to design a laboratory experiment to test the relationship between capital I and P. You need to explain how your results could be used to get a value of alpha. And yep, as always, you need to draw a diagram which has to be realistic, has to be, has to make sense. There shouldn't be anything hovering in thin air. There shouldn't be any apparatus where it shouldn't be. Everything ought to make sense in your schematic diagram. Outline procedure, measurement state analysis, and safety precautions as always. So, what sort of an experiment is this? Well, it has to do with sound and it has to do with intensity. So it may have something to do with the AS physics waves topic. So if it's sound, how do you produce sound? Sound can be produced in a lot of different ways. You can use, for example, a signal generator connected to a microphone, and you'd be like, OMG, have we ever been familiar with these particular experiments, these particular apparatus? Well, at the end of the syllabus we have these. We wrote the symbol for a microphone and the symbol for a, and I don't think we actually have it for a signal generator, sadly, but we do have it for a microphone and a loudspeaker. So I think we're going to have to use the one for a loudspeaker. So we need a signal generator and a loudspeaker, and that is going to produce sound, right? Sound of a particular frequency and a particular intensity that is going to hit the foam and is going to be reflected back. So how do we get the intensity then? We can use another circuit, right? We're going to use another circuit which has a microphone to pick up the incoming sound and an oscilloscope, because the microphone is going to convert the sound to an electrical signal, and the electrical signal will be analogous to the sound signal that so produces it, and then we can get it from that. So it's a really great idea trying to link up all that they've given with what you have. Is there anything else we know about intensity? We know intensity declines as it travels, so we want the distance between the apparatus to be constant throughout. Alright, and so what we're going to change and what is to be changed and what we should keep constant, these are the questions of the hour. So what are the variables? You can see at first glance. Intensity. What intensity? Intensity of the original sound. Intensity of the reflected sound, that is the received sound. Thickness of the foam. Density of the foam. Distance between the foam and the loudspeaker, and the foam and the microscope. The settings on the signal generator. The frequency might also be something that can affect the intensity, right? Don't take the risk anyways. So what is the independent and what is the dependent variable? The independent variable is going to be the thickness of the foam. The dependent variable is then going to be the intensity of the reflected sound. What are the constant variables? The original intensity of sound produced, the frequency of the sound produced, the density of the material, the distance between the loudspeaker and the foam, and the microphone and the foam. These are all things you need to keep constant. Right, so we have successfully identified all the variables and classified them. Next thing you really need to be careful about the drawings. They need to be realistic. Everything needs to be labeled. So yeah, let's assume that this is straight. It doesn't look weird. So we can have a circuit over here. You need to realize that we can have a loudspeaker over here. Like this. Oh! And this is a bit big of a, too big of a microphone. But it's fine. Oh my god, why do I do this? You know what? This is unnecessary. This is the unnecessary bit, right? It's like the computer doesn't want to listen to me today. So let's just cut this part out. So this is the part we want, okay? So we have the microphone that is part of this circuit with a signal generator. This is a symbol for a signal generator. Actually, it's not quite so ugly. I recommend you search what it actually looks like. I'm gonna assume that the connections aren't so terrible. This diagram drawing, this is really terrible, to be honest. Where's the god? Let's make this a bit bigger so this makes sense. We can actually even make this so that it's slightly turned in this direction, because that is going to make more sense. To me, that will make more sense if it's sort of like this. It's sort of like at an angle and not parallel to it. Like this, I mean, like the microphone is like this. You need to realize this is a lot. Let's fill this up. And this is it. This is it. And it's like inclined, alright? And here we have the signal generator. And with it we can do all the settings, right? And we have this really big wall. And we have this like foam of even thickness. Let's assume this looks even. Let's make it a bit bigger, even. So it's going to probably hit over here and it's going to like reflect, so it's going to be a bit over here. So that is where the microphone ought to be. It just needs to be an approximation, doesn't? So this is this being connected. And here we have an oscilloscope. And again, you're like, OMG, oscilloscope. we don't know what that is. You do, and you know what a circuit symbol is if you have taken a look at the end of the syllabus. It's something like this, to be honest. Right? So please, hopefully, so if it's like going from over here to lower like here, it's going to reflect by the same amount relative to the position it hits. Because from those of you who remember GCSE, you should know that this angle should be constant. So label this up, label everything up. This should be labeled, this should be labeled, this should be labeled, this should be labeled. You can even say that theta 1 is equal to theta 2, because that is the law of reflection, okay? So we've already identified what the independent and the dependent variables are, right? How to vary the thickness of the foam. You can use multiple layers of foam in order to vary the thickness, right? You can get a lot of foam and then you can vary the number of layers in order to vary the overall thickness, but you have to be sure that they're of the same density. And how do you get the density? You can take a small piece of the foam, right? And you can take the dimensions, the length, the width, and the height. You can multiply them after converting them into meters to figure out the volume. Then you can weigh them to get the mass over volume density. But again, I was getting off track. So, variable identification, vary the thickness by using different number of layers of foam of the same density, right? Taping them together to the wall. And the density of the foam can be calculated by cutting off a small piece of the foam, measuring the length, the width, and the height with the help of a vernier caliper, converting the values into meters and multiplying them together to get the volume in meters cubed, then weighing it on an electronic balance to get the mass. Density is mass over volume, right? That was a variable, obviously. And then what you can do is you can basically position a circuit with a microphone and a loudspeaker as shown in the diagram, and the distance between the microphone and the loudspeaker and the microphone and the foam and the loudspeaker and the foam should be about the same, and throughout the experiment these distances, whatever they are, ought to remain constant. Then the signal generator is turned to a particular value of amplitude, to a particular value of the intensity, which should be as big as possible so that the value of the reflected intensity is pretty big, right? Both the frequency and the amplitude have to be set at a constant value because they are potential factors. And for each value of t, you have to let the trace on the oscilloscope stabilize before measuring the height of the peak and multiplying by the y gain in order to get the value of the reflected intensity. And for each thickness, you're going to have to repeat it a few times and average it. And how do you make the thickness of the foam? To make the thickness, you need a vernier caliper, right? And so you do that loads of time. And in data analysis, my favorite or my least favorite depends really on the type of question. Log I is equal to log I naught, and you should realize that I naught is the intensity of the sound before the reflection, and that is something you can get from the settings of the signal generator minus alpha pt. So because what is the dependent and what is the independent? So we know t is the dependent, so it's on the x-axis. I is the independent y-axis. So if we plot log I against x, you should get a graph that is straight line with negative gradient, right? And c will be equivalent to log I naught. That isn't really required, but you should know what the value of I naught is, and you can get it from the signal generator. You know what the density is. You know what alpha is, that is what you want to know. And you know this value is equivalent to the gradient. So the gradient is equal to minus alpha p. So to get the value of alpha, you just have to divide the gradient by the density which you know and take the minus of it. Safety precautions. These are sound waves, so maybe using a noise cancelling headphones so your ears aren't hurt if it's a particularly loud sound. So let's take a look in the marking scheme, see how well we did. Hopefully we got full marks. So checking out the marking scheme, t is the independent variable, definitely that is what we said, and pi is the dependent. Keep distance from the wall to the speaker, the microphone constant. Keep the amplitude or intensity before reflection constant, including speaker, microphone, sound detector, foam and wall, signal generator, microphone connected to oscilloscope or sound intensity meter. Yep, but we went with this. This is correct as well. Thickness with a rule, micrometer, vernier caliper, m over v, log in against t, minus gradient over p. Use earplugs, muffs, defenders. Keep the frequency constant, quiet room. Method to keep the angles constant, position of speaker and microphone constant, something I did not write. Method to detect reflected sound from the foam only, example, barrier, tube or method. This is actually a good idea. Something I did not quite remember. Use of mass, method determine volume. Straight line is constant, or method to check y-intercept is log I naught. 1, 2, 3, 4 full marks, though there were some stuff I mentioned. This was a good idea to see that I naught is constant, or that the y-intercept is log I naught, because that would be an indication of how accurate your experiment was. And intensity is proportional to amplitude squared. So hopefully you found this helpful. If you did, please like, subscribe and comment.